Hey everybody, this is Mr. Mott. What we're going to do is go over oxidation and reduction, and we're going to do it step by step. So we're going to start out doing some notes, kind of reviewing atomic structure. And so we had covered before in class about how do you determine the number of protons and neutrons and electrons. So we're going to start out, and we have this example of lithium 0 turning into lithium plus 1. So lithium, we want to first, in the center part here, it's going to kind of represent our nucleus. And what we want to do is look on our periodic table, and lithium is atomic number 3. That means that it has 3 protons. So I'm going to write 3p+. P plus is going to be our symbol for protons. And so since it's lithium, both on our reactant and our product, we can write our 3 protons in there right away. Okay. Now, I'm going to look towards the atom here, lithium 0, to assign how many electrons there are going to be. To have an overall charge of 0, your protons and your electrons will be the same. Since we have 3 protons, we're going to have 3 electrons. Okay. I'm not going to worry about the neutrons because they don't change the charge. Even if I had 100 neutrons, it's not going to change the overall charge of the element. Okay. Now, when lithium 0 goes to lithium plus 1, we need to think about how did the electrons change. Okay. Now, so what we want to remember is that electrons are negative, and so if you gain an electron, you become more negative. Well, that's not what happened here. We have a plus 1 charge. So we must have lost 1 negative. So instead of having 3 electrons, now we have 2. And a way that you can kind of check that is you can say, well, I have 3 positive parts. I have 3 protons. That's kind of like having positive 3. And I have 2 electrons. That's kind of like having a negative 2. Well, if you add plus 3 and negative 2, you end up with plus 1, and guess what? That's your overall charge. So I have a pretty good sense, sorry I was blocking it with my hand, I have a pretty good sense that I did this correctly. So that's always a nice check you can do. Okay. Don't worry about what's going to go in this blank. We're going to come back to that later. Okay. It's another example here. We've got calcium 2+ and calcium 0. Looking on our periodic table, we have calcium is atomic number 20. So there's going to be 20 protons. And so I'm going to write 20 protons for each. Okay. Now, I find it always helpful no matter where the atom is. In this case, it's on the product side to start there because you know that the protons and the electrons will be the same. Now, what you can think about here is, well, if I have an overall plus 2 charge on calcium 2+, should you have 18 electrons or should you have 22? So, and again, this is a little bit backwards because electrons are negative. So if we have, let's try this, 18 electrons. Well, again, from your protons, sorry about that, it's a bell. So if we have 20 protons, it's kind of having like a plus 20 charge, and 18 electrons is like having a negative 18. And if you add that up, you get plus 2, and that's our charge. So we know we did that correctly. All right. A couple more different examples that we can take a look at. We've got fluorine. Is our next one. Fluorine's atomic number 9, so there's 9 protons in each. Okay. By now we should be, our strategy is to look at the atom. So we have, the atom is the one with the 0 charge. And then we have 9 protons and 9 electrons. Since fluorine, when it becomes an ion, it's a -1 charge. You can think about how many electrons. So did fluorine, to get that -1 charge, are we going to have 10 electrons or are we going to have 8? Okay, so you can maybe pause the video or if you want to think about that for a second. And let's try 10. So right now, again, we have like -10 from our electrons, +9. and that adds up to -1, and -1 is the charge, so we feel pretty good about that. Okay. What you can do maybe if you want is pause the video and you can try number 4. Okay. All right, so guessing that you unpaused the video, we got oxygen. Oxygen is atomic number 8, and so there's 8 protons, and we can write that in for both. Here's our oxygen atom, so there's going to be 8 electrons there. And a -2 says that you've got 2 extra electrons, so you're going to have 10 electrons. All right, and if you feel good about that, you can try that last one here. Go ahead and pause the video and try this on your own. Okay. All right. So now with copper, copper is going to be atomic number 29. Okay. So copper, we're going to write 29 protons in each. And this time we don't have an atom here, so that definitely makes it a little bit trickier. And so, all right, we have +1 charge on the right. We could start on either side. I'll start here. +1 charge on the right. So we need to have more protons here than we have electrons, so we have an overall positive charge. That's another way of thinking about it. So we have, let's see, so we must have 28 electrons. So 29 positive, 28 electrons, you add that up, you get +1. Similarly, we're going to have 27 electrons here. So again, you can always double check that. +29 from your protons, -27, you get a +2, and the +2 is what the charge is. Okay? So I find it helpful to think about and have this visual picture about when atoms become ions and ions become atoms, what's happening in terms of the atom. And what we can see from all of our examples is that it's the electrons that are changing. Okay, we never change the number of protons, always the number of electrons. So now what we can do is we can think about a couple things. One is that if in this first example, lithium starts out with 3 electrons and now goes to 2, it kind of looks like matter is being destroyed. It looks like we're destroying an electron. Since we know we can't do that, what we do as chemists to balance things out, we're going to add 1 electron here on the right-hand side. Okay? And so now this 1 electron plus the 2, we have 3 total electrons on the right and then 3 on the left, so everything's balanced. We didn't destroy matter. The other thing we can, and so we can go ahead and try that for each, so balance things out. So in the second example, we have 18 electrons on the left and 20 on the right. So to balance this out, we need to add 2 more electrons to the left-hand side, so we can add them right here. Okay. You pause the video, you can try numbers 3, 4, and 5 and see what we come up with. All right. Now that you're back from pausing the video, we should add 1 electron on the left-hand side. So we have 1 plus 9, which is 10. You have 10 on each side. For number 4, we're going to have, since we have 10 here and 8, we're going to have to add 2 electrons here. And then for number 5, we have 27 electrons to 28, so we're going to add 1 more on the left-hand side. All right. Now, to introduce some terminology, we can take a couple notes here at the top. And there's different terms when you consider whether an atom or when something is gaining or losing electrons. And so what scientists have come up with, and it had to do with the initial reactions that they were observing, they said that when you lose electrons, it's called oxidation. Okay, and when you gain electrons, it's called reduction. So how we can remember that's a little mnemonic device. We say that Leo goes grr. Okay, Leo goes grr, and that's a way for us to remember what you call it when you gain or lose electrons. So if we apply this to our examples here, and we look at number 1, okay, your frame of reference is always your reactant. If it went from 3 electrons to 2, this lost electrons, so it lost electrons, so this is oxidation. Okay. For number 2, we went from 18 electrons to 20, so this species, this calcium 2+, needed to gain 2 electrons. So gaining electrons is reduction. Grr. Gain electrons is reduction. All right. We can try number 3 here. F0, so we started at 9 electrons, and then we went to 10. So this species needed to gain 1 electron to become F-. So again, this is gaining electrons. Okay, and so this is your reduction. For number 4, we had started with 10 electrons and we ended up with 8. So this species lost 2 electrons to become this. So this is losing electrons is oxidation. And number 5 says down here we've got copper 2+, or we start out with 27 electrons, you end up with 28. This species here, your reactant needed to gain 1 electron, so this is reduction. Okay? So your frame of reference is always your reactant. What did your reactant need to do to become the product? And by drawing out this atomic picture is a good way to see how the electrons changed. Oftentimes students get this a little bit mixed up because when they're thinking about gaining or losing, we often forget that when you're gaining or losing, we're gaining or losing electrons, which are negative. So everything's kind of opposite. So hope that helped understand a little bit about these oxidation and reductions. These are known as half reactions, and in the next video what we're going to do is look at oxidation and reduction half reactions within an actual chemical reaction. All right, thanks for watching, everybody.